In the vast expanse of modern physics, few questions captivate both scientists and philosophers, quite like the intersection of quantum mechanics and free will. As we peer into the enigmatic world of quantum phenomena, we encounter a universe that defies our classical intuitions and challenges our most basic assumptions about cause and effect, determinism, and the nature of reality itself. For centuries, scientists believed in a purely deterministic universe, where every event followed inevitably from prior conditions, like an impossibly complex chain of falling dominoes. This worldview left little room for genuine free will, suggesting our choices were merely the predetermined results of prior causes. But quantum mechanics shattered this neat, clockwork universe, revealing a reality where uncertainty and probability reign supreme. At the heart of this revolution lies Heisenberg's uncertainty principle, which tells us that we can never simultaneously know both the position and momentum of a particle with perfect precision. This isn't merely a limitation of our measuring instruments. It's a fundamental feature of reality itself. Particles exist in multiple states simultaneously, until measured, described by probability waves rather than definite positions. This quantum uncertainty introduces an element of genuine randomness into the fabric of the universe, breaking the chain of pure cause and effect that classical physics had established. But does this quantum uncertainty actually help explain free will? Some physicists and philosophers argue that it does. They suggest that the indeterminacy at the quantum level could cascade up to influence the behavior of neurons in our brains, creating windows of opportunity where our conscious decisions might genuinely shape future outcomes. In this view, quantum mechanics doesn't prove free will exists, but it creates the possibility for it by breaking the rigid chains of classical determinism. Others remain skeptical, pointing out that replacing determinism with randomness doesn't necessarily get us any closer to true free will. After all, if our decisions are merely the product of random quantum fluctuations, are we any more free than if they were predetermined? Random choices, they argue, are not the same as free choices. We seem to want something more, decisions that are neither purely determined nor purely random, but somehow arise from our conscious deliberation and genuine agency. The debate becomes even more complex when we consider the role of consciousness in quantum mechanics. The famous measurement problem suggests that conscious observation somehow collapses quantum probability waves into definite states. This has led some theorists to propose that consciousness itself might be fundamentally connected to quantum processes, though many physicists regard such speculations with skepticism. Looking deeper into the quantum realm, we encounter phenomena like quantum entanglement, where particles maintain instantaneous connections across vast distances, seemingly defying Einstein's speed of light limit. These spooky actions at a distance, as Einstein called them, hint at levels of interconnectedness in nature that we're only beginning to understand. Could our conscious decisions be similarly entangled with the quantum fabric of reality in ways we haven't yet grasped? Modern research continues to probe these questions from multiple angles. Neuroscientists study quantum effects in brain processes, while physicists develop increasingly sophisticated experiments to test the foundations of quantum mechanics. Philosophers work to reconcile these findings with our intuitions about free will and consciousness. The challenge lies in bridging the gap between the microscopic quantum world and the macroscopic realm of human experience and decision-making. What emerges is a picture of remarkable complexity. We find ourselves in a universe where strict determinism has been definitively overthrown, yet true randomness may not be the whole story either. The quantum realm reveals layers of reality that defy our classical intuitions, suggesting possibilities we're only beginning to explore. Perhaps free will exists in some middle ground between determinism and randomness, emerging from the complex interplay of quantum processes, biological systems, and conscious awareness. As we push the boundaries of quantum theory and neuroscience, we may discover new frameworks for understanding how human choice and agency could arise from the fundamental laws of physics. The question of free will remains open, but quantum mechanics has transformed the nature of the debate, replacing rigid determinism with a more nuanced picture of probability, uncertainty, and possibility. What's clear is that the intersection of quantum mechanics and free will forces us to confront the limits of our understanding and the profound mysteries that still lie at the heart of existence. As we continue to explore these frontiers, we may find that the truth about free will is even stranger and more fascinating than we imagined. The quest to understand these fundamental aspects of reality drives us forward, reminding us that in science, as in life, the journey of discovery is often as enlightening as the destination.